Okay, can we start? So today we will look at the second part. Before spring break, we looked at the anatomy of the respiratory system. So now we look at some of the physiology part, the lung function tests. Okay, so I don't anticipate the lab to be, in fact, according to the syllabus today is urinary system, but we are way behind. We will start urinary system next Monday. But before we begin, let me tell you the exam details, okay? So lecture exam 2. Lecture exam number 2. Okay. So this is going to be on the topics. We haven't done the cardiovascular system. The first exam was endocrine system and blood. So this is the cardiovascular system. And respiratory system. Two systems, these are fairly, content heavy, so two systems. And we will have this exam, it was supposed to be this Wednesday, if you look at your schedule. We'll have it next Wednesday, okay, which is April 1st, okay. April 1st. April Fool's Day, but you will definitely have the exam, okay? So, April 1st. That's lecture exam number 2. Now, for the lab exam 2. This would include respiratory system anatomy and physiology, what we are going to learn today. And I will just check if I haven't posted the lab exam study guide. I will do that, okay, this evening. Respiratory system anatomy and physiology and urinary system. Urinary system, which is the next body system that we are going to talk about. Urinary system, anatomy and physiology. So this will be, so today we'll finish respiratory system, then we'll do urinary system. In the next Monday, we will do that. And then April 6th, Monday, April 6th. Monday, April 6th will be your lab exam. Wednesday, April 1st will be your lecture exam. And the mastering homework assignments on cardiovascular and respiratory, I will extend the due date to April 1st till the exam date. Okay, if you haven't done it, make sure you do that. I think I got the dates right. Yes. Okay. Any questions? Topics I've told you. Under each cardiovascular system, you have the review questions. Under respiratory system module, you have the review questions. That is your study guide for the exam. Okay? So, Wednesday, Monday, we should finish respiratory system. Okay? So that is the announcement that I wanted to give you in the lecture class, but I hope all of you got it. If any of your friends are not in class today, just let them know. Okay? Right, so let's look at respiratory system physiology, which is actually 13B. So this deals with some of the tests that we normally do for assessing respiratory function. So first we'll start with the ventilation, pulmonary ventilation. Okay, if you can open up to page 149, you will be able to see a picture there. And so the pulmonary ventilation that we spoke about just now, how air moves in and out of the lungs. Okay, so inspiration and expiration. let me just reiterate that again so you are actually going to create a negative pressure inside your chest cavity. So at the end of your normal breathing, your diaphragm is dome shaped, your lungs are back to their original position, and the pressure inside the lungs, which is called the intrapulmonary pressure, and the atmospheric pressure are in equilibrium. So let me summarize that. Before start of breathing, diaphragm relaxed, chest wall is in the relaxed state, intrapulmonary pressure, that is the pressure of air inside the lungs. Intrapulmonary pressure is equal to atmospheric pressure. That is 760 millimeters of mercury. So when the pressure is the same, there is no movement of air. Okay? So this is 760 millimeters of mercury, and this is also 760 millimeters of mercury. Okay? Let me get rid of this so that I can, okay, just switch this off for a time being so that I can explain this to you and then show you. So during inspiration, what are the changes that take place? Okay. Diaphragm contracts, and flattens. Okay, diaphragm contracts and flattens. The chest wall and rib cage expands. What are the muscles that help to lift your rib cage and open up your rib cage? External intercostal muscles. Very good. So this is brought about by contraction of external intercostal muscles. So the two main muscle groups that are needed for normal quiet breathing. You're not exerting yourself, there's no exercise, nothing. Diaphragm and external intercostals. These are the two main muscles of inspiration. If any of these muscles are paralyzed, breathing in is not going to be possible. Okay, diaphragm and external intercostal muscles are referred to as the main muscles of inspiration. Okay. So when they do this, when the diaphragm becomes flat and the chest wall and the rib cage expands, this causes the lungs to expand and the intrapulmonary pressure that is the pressure of air inside the lungs, intrapulmonary pressure decreases. Okay. So atmospheric pressure at this time is 760 millimeters of mercury, and then the intrapulmonary pressure, PIP, okay, intrapulmonary pressure is 759 millimeters of mercury. Okay. What explains this decrease in the intrapulmonary pressure? It is the Boyle's law. It is the Boyle's law. When volume increases, pressure of the gas inside the chamber decreases. That is Boyle's law. Okay? So, when, if you want to remember this, when volume increases, pressure decreases. Okay. So again, these are very basic foundation concepts which you should know. Okay, that's why I'm repeating it. So there is a decrease of 1 millimeter of mercury. So air moves into the lungs. Okay, that's inspiration for you. During expiration, air moves into the lungs until intrapulmonary pressure and atmospheric pressure comes to an equilibrium. They become equal. And that's when inspiration will stop. Okay, until the two pressures become equal. During expiration, diaphragm and lungs recoil. That is because the elastic structures, they go back to their original position. The chest wall and rib cage recoil, go back to their original state. Okay? So please note there is no active muscle contraction to bring your chest wall or your diaphragm back. The diaphragm just relaxes, the lungs also recoil, the chest wall recoils. So quiet, when you're breathing quietly, energy is needed for this. ATP is needed for contracting the diaphragm, for contracting the external intercostals and lifting your rib cage. Whereas expiration is a passive process. Everything just goes back to its normal state. So you're not using any energy for this. So inspiration, quiet inspiration is an active process. Active because you're using energy for this. Whereas quiet expiration is a passive process, no energy needed. It's a passive process. Once the diaphragm recoils, the chest wall recoils, the lungs recoil. So the intrapulmonary pressure increases. The intrapulmonary pressure increases as the volume of the thoracic cavity decreases. According to the Boyle's law, that's because the volume decreases, pressure will go up. So it increases to about 761 millimeters of mercury. 1 millimeter of mercury higher than atmospheric pressure. So because of that, air moves out of the lungs. Okay? Until the inside and the outside become 760. Air moves out of the lungs until you reach this state. And then again, it repeats itself. So this is something that you can sort of show with this. This is called the bell jar model. It's on page 149, the bell jar model. The plastic jar that you see, this represents the rib cage. This represents your chest wall and your ribs. What's this? This polyethylene flap that you see here. This represents the diaphragm. This represents the diaphragm. The little balloons inside represent the two lungs, and then there is a hole here through which air can enter. So you could think of this as the air passage or the trachea. Okay, so see what happens. So this is the original shape of the diaphragm. So it's like a dome. So the central portion is elevated. This is the relaxed state of the diaphragm. So you can see that the volume of that bell jar is now reduced. So you see what's happening to the balloons. Okay, and now I'm going to simulate the contraction of the diaphragm. So it's going to become flat. Okay. When I pull the diaphragm and make it flat, the lungs have expanded. Why? Because the volume of that cavity has increased, so the pressure inside the balloon is less. Air gets drawn into the balloons. Making sense? Okay. So this is a bell jar model. This represents your chest wall. This represents the diaphragm. The balloons represent the lungs. And the space between the balloon and the plastic shield, the dome, represents the intrapleural space. Although the intrapleural space is not going to be so big, it's going to be a tiny microscopic space. But that's what it represents. Okay? So when the volume of the bell jar is reduced, the pressure inside the lungs becomes higher inside the balloon and air escapes out. And when you flatten the diaphragm, when it contracts, volume of the cage is higher, so the pressure inside the balloon is low, so air gets sucked into the balloons. Okay? Now will you be able to answer the questions that are there in that based on this? And you can try this out. We have a few, so you can try it out once we finish. There are some things that you're going to do, so you can try it out. Okay, see, it's a very simple thing over there. So we just did that. Yes. Got increased or decreased? Pressure will increase. Why did the pressure increase? Because the volume has decreased. Okay? It's always the volume that is changing in order to change the pressure. So the volume of the thoracic cavity is decreasing, and that's why the pressure is increasing. Okay? And what is happening to the volume of the lungs? What happens when you push the diaphragm up? Air is going out of the lungs or entering the lungs? Exiting the lungs. So the volume of the lung, air is volume. The amount of air in the lungs is decreasing. It's not a very right way of asking it. It should probably have said what is happening to the amount of air, volume of air in the lungs. Okay, so that is decreasing. Now slowly release the diaphragm. This represents the diaphragm flattening out as it contracts. What is happening to the pressure as you release the diaphragm? That means as you pull it down. The pressure is decreasing. Okay? And what happened to the volume of the lungs? The air is being sucked into the lungs. The volume of the lungs increases. Okay? Does it make sense? So right here probably you should make a note. Quiet breathing Inspiration is an active process because it involves contraction of the diaphragm and the external intercostal muscles. So all the ATP that you're making, you're using it for just normal breathing. Your body has to make ATP all the time, and it is being used for just quiet breathing. Okay, so quiet inspiration is an active process because of the contraction of the diaphragm and the external intercostal muscles. Expiration, please write down, it is a passive process due to the recoil of the diaphragm, the lungs, and the chest wall. So they just go back, elastic recoil, they just go back to their original position. Now when you exercise, do you think this will be enough? No, because exercise requires a lot more air to be taken in, lot more oxygen to be given to your tissues, lot more carbon dioxide to be removed. So during exercise, you have seen after a jog, run, once you have exercised, you can see that you are breathing more deeply. So the diaphragm and the external intercostals alone are not important. What is this muscle that is attached to your first rib here? The clavicle. What muscle is this? Sternocleidomastoid. So the sternocleidomastoid lifts your clavicle and your first rib up. Okay? Now, what are the muscles on the sides of your rib cage which have a sawtooth-like appearance? Serratus, the serratus anterior. So serratus muscles also pull your rib cage even further. What is the muscle in the front of your rib cage that can also pull your rib cage forwards like that? What is this muscle here? Pectoral muscles, the pectoralis, okay? The pectoralis minor can lift the ribs. So these are called accessory muscles of inspiration, accessory muscles. Accessory because they only work when you need extra effort during exercise. So accessory muscles of inspiration, which play a part when you are exercising. Sternocleidomastoid, pectoralis, okay, to a certain extent major and minor, serratus anterior, and the scalene muscles. Scalene. These are all called accessory muscles of inspiration because they help to expand your rib cage even more. So then the volume of your chest increases further, the pressure drops even much lower. It won't drop just by 1 millimeter of mercury, it will drop even further by 5 or 6 millimeters of mercury, so more air gets sucked in. Okay? And then you also have, when you're exercising, to blow out more air. It's not enough. The diaphragm recoiling and the chest wall recoiling is not enough. You actually need other muscles that can also push air out. So accessory muscles of expiration, okay, all your abdominal muscles, all the abdominal muscles, okay, rectus abdominis, your external oblique, transversus abdominis, external oblique, internal oblique, all the muscles that you learned. Transversus abdominis. So these are all called your abdominal wall muscles. in front. And of course, what's the other intercostal muscle that can pull your rib cage down? Internal intercostals. So internal intercostals. Internal intercostal. Too busy, not nice, right? You don't know what is what. But anyway, so accessory muscles of inspiration, all the muscles that can lift your rib cage, and accessory muscles of expiration, all the muscles that can push the diaphragm even further up, which is all these. And then the internal intercostals, which will pull your rib cage back so that more air can be pushed out. So your thoracic cage will become even more smaller. The diaphragm is pushed even further, and then the pressure inside will increase, not by just 1 millimeter, it will increase by about 6 or 7, and so air will be pushed out. Okay, that is about the normal inspiration and expiration. So the next thing is, whenever somebody has a respiratory disorder, a problem with the lungs, we do, in the clinic, they do something called lung function test or respiratory function tests, okay, to see whether the breathing process is normal, whether the amount of air entering the lungs is normal or not, okay. So it's a very common thing that is done, especially when you suspect that somebody has some lung issues. So we're going to look at some of those tests, and you're going to understand what these tests are, and then you're going to try it out as well. We have the instrument for that. Okay, so if you can open up to page 150 and just follow the explanation that I'm going to give you. Okay, page 150, the figure that is there, that is what you normally assess. So this is the lung function test. And the instrument that is generally used for performing the lung function test is called a spirometer. Lung function test. The instrument that we use is called a spirometer. Okay, we'll probably look at that. Some of you may have seen this being done. Spirometer, that's the instrument. Something like this. This is a sophisticated spirometer where the patient is asked to, the nose is blocked off or the nose is clipped, and the person breathes in and out through a tube, and then the computer records it. Okay, this is what you have nowadays. Of course, in the lab here we don't have this. We have something called a handheld spirometer, which you will be using, and just have fun with it. Try some things. This is what you will be using, a handheld spirometer, to look at some of your lung function. Okay, how good your lungs are, how healthy they are. So, what do we find from this lung function test? We can find out 4 lung volumes. Okay, 4 lung volumes, and using those volumes we can calculate 4 lung capacities. So 4 lung volumes and 4 lung capacities. Okay. Now, this is nothing but the amount of air that enters your lungs or leaves your lungs. That's what it is. Okay. Now, the significant thing about the respiratory system is that this is one internal organ system which can be controlled consciously. So, voluntarily you can do things to it. So, if you are asked to take a deep breath, you can do that. Okay, it's a voluntary act, but you can do that. If I ask you to hold your breath, you can also do that. So, whereas if I ask you increase your heart rate, you can't do that unless you exercise, okay, or decrease your heart rate. You can't do that voluntarily. So, the respiratory system is one system which also has a voluntary act. You can control it or you can adjust it based on your conscious thinking. Okay? So, that's the basis of some of these tests that we do. Okay? So, what are the 4 lung volumes? I'm going to name them to you and then we'll see what it is. Tidal volume, inspiratory reserve volume, expiratory reserve volume. Now, you already know what inspiration means, what expiration means. Last one, residual volume. Residual volume. And we do have short forms for this. Tidal volume is usually shortened as TV. Inspiratory reserve volume is IRV. Expiratory reserve volume is ERV. And residual volume is RV. And then we calculate using these volumes. But this is what we measure. So, using the spirometer, you can measure tidal volume, inspiratory reserve volume, expiratory reserve volume, okay? And then you can also measure a capacity, okay? So, let's start with this. What does this mean? Tidal volume, the definition, and most of it is all there in your book, so if you don't have to write it down, but remember what they are. Tidal volume is the amount of air breathed in or breathed out, not and, or breathed out during quiet breathing. So, when you're breathing quietly, no exercise, no activity, amount of air breathed in or, why is this making a noise? I thought I silenced it. Yes. Breathed in or breathed out. That is tidal volume. So, suppose I'm recording your normal breathing. It's going to look like this. Breathe in, breathe out. Breathe in, breathe out. Breathe in, breathe out. Okay? How much of air do we normally breathe in and breathe out? It is roughly 500 milliliters. That is that little bottle that you have, the bottle of water that you buy, 500 ml. That is the amount of air that you breathe in or breathe out every time you are inspiring or expiring. 500 ml goes in, 500 ml comes out. Okay, this is tidal volume. So, take a look at that graph, that small curve that you see. That is tidal volume. Now, from this point, after you have breathed out, if I ask you all to take a deep breath, you can all do it. But in different, some of you can do if you're an athlete, you can really breathe in a lot more air than someone who doesn't exercise. So if I ask you to breathe in from this portion, okay, you can definitely breathe in an extra amount of air. Okay, you can definitely do that, and you can blow it out as well. Okay, so this extra amount of air that you can breathe in, so this is tidal volume, this normal volume that you breathe. But over and above this tidal volume, if I ask you to take in more air, you can definitely do that. So the extra amount of air that you can breathe in forcefully, this is called inspiratory reserve volume. So it's a reserve that you can use whenever you need it, like exercise, maximum exercise. Inspiratory reserve volume. This can be as much as 3000 ml or 3 liters. 3 liters. Extra air that you can breathe whenever you need it. Okay, this is what helps you during exercise. This is inspiratory reserve volume. Now, if I tell you, blow air into this balloon or blow air into this instrument, you can definitely blow out air. You can blow out air over and above that 500 ml. So normally you blow out 500, but if I ask you to forcefully blow out some air, you can do that. That extra amount of air that you are able to breathe out is called expiratory reserve volume. Now, this expiratory reserve volume is not as high as inspiratory, because when you expand your chest, you can do that. But you cannot constrict your chest. There is a limit. You cannot constrict it further than that. So this expiratory reserve volume is roughly half this amount, about 1200 to 1500 ml, only half of that, because you really cannot, constrict your chest to beyond a certain degree. So that's your third volume. So the first volume is tidal volume, second inspiratory reserve volume, the extra amount of air that you can breathe in over and above that 500 ml is called inspiratory reserve volume. The extra amount of air that you can blow out forcefully over and above the 500 ml is called expiratory reserve volume. Okay, and then this is again normal breathing. Now, no matter how hard you try, there is some amount of air that you can never empty out. You cannot empty it out, no matter how hard you try. There will always be some air left in the alveoli and left in the respiratory system after a forced expiration. Even after you blow out all the air, there is still some air left in the lungs. And that is your fourth one, called residual volume. The residual volume is generally equal to about 1200 ml. So these are the 4 lung volumes that you see in a healthy individual. Now, all of these volumes will change. They will be different. Not all of us will have the same. It will depend on the sex of the individual, male or female. It will depend on the body size of the individual, the muscle mass, the level of physical fitness, and the presence or absence of disease. Okay? So these values will change. But in a healthy individual, it should somewhere fall in that range. Of course, a smaller built individual will have smaller volumes. A large built individual will have higher volumes. person who's an athlete will have much better numbers than someone who doesn't exercise. So it will change, but overall it's in this category. Okay? Tidal volume, quiet breathing. 500 ml goes in, 500 ml comes out. Inspiratory reserve volume, the extra amount of air that you can breathe. Expiratory reserve, you forcefully blow out air, that's expiratory reserve volume. And the air that you can never empty from your lungs, residual volume. Okay? So this is something that we use, like in forensics, they use this to figure out whether a baby, a newborn baby, was either born dead, was it born dead, or did it die after birth? Okay? You can use this. If it is born dead, if the baby is still born, the lungs will have no air in it. But if the baby died after birth, that means it took its first breath, took a few breaths, and then died, you will find air in the lungs. How can that be? How can you quickly determine that? You take the lungs out and then, how can you determine that? Any idea? Huh? Feel it? Okay, maybe. What's the other thing? A lung that is solid, which has no air in it, if you put it in water, it will sink. A lung that has air in it, what will it do? It will float. Okay, that's what they do in cases of, when there is a suspicion that whether the child was killed after it was born or whether it was born dead, the autopsy surgeon will do this. They will take out the lungs and then they will put it in water. If it floats, that means the baby died after birth. If it sinks, that means the lungs did not expand, the child was born dead, the baby was born dead. Okay? So some amount of air is always there in the lungs. You can never remove it. The lungs can never be emptied of air. Just like in the heart, we saw the heart pumps the stroke volume and there is still some amount of blood left in the ventricles. It never pumps it completely out. Ventricles never empty themselves. The same thing applies here. The lungs never empty themselves. Okay? So that is about the 4 volumes. The 4 capacities are additions of these volumes. Okay? If you add, so there are 4 capacities which you can and you can actually try this out with the handheld spirometer. It's not going to give you accurate results, but at least just you can have fun with it. But this is exactly what is done in the hospital setup if you want to check the lung function test. So the 4 lung capacities, the first one is called inspiratory capacity. Inspiratory capacity. Inspiratory capacity is tidal volume plus inspiratory reserve volume, that is 500 plus 3000. This entire thing, 1 and 2 together, 1 plus 2. Second, functional residual capacity. Functional residual capacity is the other side, okay? It is this one. ERV plus residual volume is functional residual capacity. This one, the air that is left in the lungs after a quiet expiration. This plus this is functional residual capacity. The third one, which is actually the important capacity, is called vital capacity. Vital capacity is IRV plus tidal volume plus ERV. So 1 is tidal volume, 2 is IRV, 3 is ERV. This is vital capacity. Very important, because vital capacity gives you a quick idea about the health of the respiratory system, the lungs, how healthy they are. How can we measure vital capacity? We measure vital capacity like this. We ask the patient, we ask the individual to take a deep breath as much as they can, fill their lungs with air. And then we ask them to blow out air as quickly and as fast and as much as possible. So they blow out the inspiratory reserve volume, tidal volume, expiratory reserve volume. What they cannot blow out is this residual volume. This won't come out. So that extra amount of air that they breathe, IRV, tidal volume, and this is your expiratory reserve volume. So this is how we ask them to do the vital capacity. So they start after expiration, start taking a deep breath. Fill the lungs with air as much as possible. And once they reach that peak, then blow out all the air as quickly and as forcefully as they can. So all of this will come out, and you can measure the amount of air that they blow out. That will be the vital capacity. Vital capacity is a very good indicator of lung health. And the last one, last capacity, fourth one, total lung capacity. Total lung capacity. Total lung capacity, as the name indicates, is an addition of all the volumes. Tidal volume plus IRV plus ERV plus residual volume. And if you actually add all those volumes, you will see that the total lung capacity for a healthy young individual is 5,000 to 6,000 ml or 5 to 6 liters, exactly similar to your blood volume. Okay, similar to your blood volume. So your lung has the capacity to breathe in a lot more air. Okay, so we use the handheld spirometer to measure this. You can't measure all of them. Obviously, you cannot measure residual volume. This is something we calculate. Okay, we cannot measure it. There is a way of measuring in experimental animals, but we don't do it in humans. We can do it, but not generally done. So the way we calculate residual volume is if you want to find out residual volume, if you know the total lung capacity and then you subtract the vital capacity from that, you get residual volume. Okay, so vital capacity is IRV plus TV plus ERV. Total lung capacity is all the same three plus residual volume. So if you subtract vital capacity from total lung capacity, you can get this value. You can get residual volume. So residual volume is generally not measured so much. Vital capacity is measured. So I want you to take a look. If you can open up to page 152. Open up to page 152. Okay, let's take a look at this one. I want you all to do. Just try it out because we are going to then look at a measurement later. obtain a disposable mouthpiece and attach it to the end. Okay, so we have disposable mouthpieces here, and this is your spirometer. This is your handheld spirometer with a pressure recording device. Okay, what's shown on your picture, the same thing. Now what I would like you to try out, make sure you follow it correctly. Okay, please read it. Before you begin, practice exhaling through the tube several times. Okay. Whenever you do the procedure, you must pinch your nose, because you shouldn't breathe out through your nose. You have to breathe out through the mouth into that spirometer. So try to do the first, number 3, try to do number 3, 4, and I definitely want you to do number 5. Number 5, I want everybody to do it. Take 3 measurements, because each time will be different, and then you will take an average. Okay? Definitely do number 5, everybody. Number 4 and number 3 also, if you can. But follow what is written there. Please follow what's written there. Otherwise, you will get false readings. You will not get the right reading. Okay, take the, those are the spirometers. Okay. So you probably don't have one for each student. We don't have one for each. You may have to share the spirometer, but the mouthpieces, obviously you have to change. Okay? And the mouthpiece can go into the regular trash after you finish. How many of you know this? Okay, those of you who work in a hospital, I'm sure you know this. This is called the pulse oximeter. We do have a lot of pulse oximeters. You can actually test it out. Now the pulse oximeter, this is a very easy device that will give you an idea about the oxygen levels in the patient. Okay? Now the pulse oximeter reads the blood flowing through the capillaries of your fingers. So you just clip it on. It gives you your pulse rate. It can give you your pulse rate. And the thing that it gives you, this percentage that it gives you, this represents the amount of hemoglobin that is bound to oxygen. The percentage of hemoglobin bound to oxygen. So how much of your hemoglobin is saturated with oxygen? So the normal value should be anywhere upwards of 90%. It should be more than 90%. That is, more than 90% of your hemoglobin should be bound to oxygen. Okay, that means your tissues are getting enough oxygen. They are not suffering from hypoxia. The moment this becomes less than 90%, then as a nurse, you would have to be concerned. You would have to start oxygen, you have to give oxygen from outside. So when there is a little bit of the physiology that you have to learn in order to understand what I'm talking about. But for the time being, just remember that the pulse oximeter is a quick way of measuring the saturation of hemoglobin. That is the amount of hemoglobin bound to oxygen. And it has to be above 92%, okay, in a normal healthy individual. The moment it becomes 90% or less than 90%, that means the tissues are not getting enough oxygen, okay, and it is a cause for concern and probably requires oxygen to be supplemented for the patient, okay. So, of course, this is not very accurate. Sometimes it can give you false reading. If you put it on each finger, you might see different readings. So just test it out and see, okay. You will know your heart rate, and then you will see a percentage here, saturation, okay. So test this out, and please remember this, That's why I put it up as a title. Remember what it shows. It is showing you the percentage of hemoglobin that is bound to oxygen. Okay, please remember that. So try this out. There are quite a few here. Try them out. Hopefully they're all working properly. I don't know. Try it out. Even I'm going to try one and see. Maybe one.
Yeah, it was a cougar, a bear, and maybe a badger.
139 is 13A quiz. Again, I'm not asking you to do all of them. So do question number 1 to question number 14. 1 to 14. Page 13A, page 139. It starts at 139, question number 1 to question number 14, which is page 142. Okay, got it? Now for the 13B, which is what we did today, again, it would be a good idea to do question number 1 on page 157. Question number 1 to question number 7. 157, yes, the page. So I just want you to do number 1 to number 7. It's always a good idea to look at the other questions. I mean, it's not that, but just to minimize the amount of, because you have to study as well. So, but this will help you to revise the different volumes and capacities. So 1 to 7 for Unit 13B quiz. Unit 13A quiz is 1 to 14. Clear? Yes?
For the lab exam.